Unit 7, Circles, Lesson 3, Inscribed Angles. Your objective for this lesson is to apply properties of inscribed angles to solve problems. Okay, so an inscribed angle is different from a central angle, which we've already looked at. This angle has a vertex on the circle, so such as E, see E is on the circle, and the sides contain chords of the circle. So it's right here. Angle DEF is an inscribed angle. Okay, and you can see here that this says that the measure of angle DEF, our inscribed angle, is half of the measure of DF, so arc DF, which is called the intercepted arc. And that is basically what the inscribed angle theorem says. It says if an angle is inscribed in a circle, then the measures of the angle equals 1/2 the measure of its intercepted arc. So right here, if angle DEF, for instance, was 30 degrees, then the intercepted arc would be 60 degrees. Okay, and you can see if two inscribed angles intercept the same arc or congruent arcs, then the angles are congruent. So that means if I had another angle over here, maybe this is DHF. You can see that DEF and DHF both intercept arc DF. That means that these are both 30 degrees then. Okay. In circle G, the measure of arc DF equals 90. So my arc, my intercepted arc, is 90 degrees. Find the measure of DEF. Okay. So I know that the measure of the inscribed angle, all right, this way, inscribed angle is half of the intercepted arc. So therefore, the measure of angle DEF is half of the 90 degrees. Half of 90 is 45. So this is 45 degrees. Now, let me share with you how I remember that it's the inscribed angle that's half of the arc, that the arc is bigger. I imagine like a slingshot. Okay, so at first, the slingshot, the part that you pull back, is up here close to the angle. But the further back you go, the smaller the portion for you to put your finger on gets. Okay, it gets smaller and smaller and smaller. It's kind of like you're moving further away, just like this. You're moving further away, so it gets smaller. So that's just like a visual for you. It might help you, it might not. You might just have to memorize this formula. But it helps me to remember that this is the smaller one, so it's half the bigger one. Okay, an inscribed polygon, let me cover some of this up, is a polygon whose sides are chords of a circle and whose vertices are points on the circle. Let me draw you an example of that quickly. So if we have a circle here, this is a little too big. Okay. I could have an inscribed triangle like this. So you see that the vertices of the triangle are all on the circle. So here, here, and here. And then the sides are chords because both endpoints are on the circle. That's an inscribed triangle. But you could inscribe any polygon into a circle. An inscribed angle of a triangle intercepts a diameter or a semicircle if and only if the angle is a right angle. So this is only going to happen if you have a right triangle. And we have this second theorem here saying that if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Okay. So those are helpful for us. Okay. So you can see here that we do have a quadrilateral, and since this quadrilateral is inscribed in the circle, I could say that angle B and angle D, if I add those together, equals 180, because supplementary, remember, means they add to 180. And I could say, oh, maybe I should mark those congruent. And I could say that A and C would also add up to 180 degrees. Okay. Example 2. Find the measure of angle K. So we have a circle and a triangle that is inscribed into the circle. And it's not really clear, but this 3x plus 5 goes with angle L. Okay, so a few things that we want to look at here. I see I have some arcs that are marked congruent. And arc KM is the intercepted arc for angle KLM. And this one here, arc KL is the intercepted arc for angle KML. Okay, so those are the two base angles of my triangle. However, remember, when two arcs are the same, the angles that go with them are also the same. So in this case, I can determine that angle L is congruent to angle M. Okay, because those are inscribed angles and their intercepted arcs are congruent. Okay, because intercepted arcs are congruent. Okay. So basically, I know that there are 180 degrees in my triangle, and I'm going to get from there 5x plus 5 plus 3x plus 5, that's L, and then M is also 3x plus 5. Okay, so this is K, L, M. Now I'm going to combine like terms. I see 3 sets of x's. 5 plus 3 plus 3 is 11. So I have 11x. And 5 plus 5 plus 5 is 15. So 11x plus 15, and 180 stays here. Now let's subtract 15 from both sides to get the x's by themselves. Oh gosh, let me write that a little bit better. Okay, so 180 minus 15 is 165. So I have 11x equals 165. Now we're going to divide by 11, and we're left with x is 15. But again, this problem doesn't ask you to solve for x, it asks you to find the measure of angle K. So we're going to take this 15 and plug it in. Take this and plug it in. So we end up with 5 times 15 plus 5. 5 times 15 is 75, plus 5 gives me 80. So the measure of angle K is 80 degrees. Okay? And that is it for lesson 3.